Hi everybody, we're going to talk about completing the square, and I might rant and rave a little bit about why it's better than the quadratic formula, but for the most part I'm just going to talk about the process itself and remind you of how it works. So remember that completing the square comes because we want to solve some quadratic, like say, I don't know, I'm going to make one up here, 3x squared minus 7x plus 4 equals 11. That, something like that. And we're going to use the process to help us figure out how we want to not figure out how we want to, but take us through the process of getting the answer for x, or actually the answers. There'll be two of them. And the first thing that we're going to have to do is this 3 here. That 3 has got to go. In order to complete the square, we want just an x squared, no coefficient in front of it. And the way that you handle that is you divide everything by that number, every piece. So we wind up with 3 over 3, which is 1. 1 times x squared is just x squared, minus 7 over 3 times x, plus 4 over 3 equals 11 over 3. Now, don't panic because of the fractions. They're there. It's okay that they're there. We want all of the just regular numbers, what we call the constants, on this side over here. And so I'm going to take the 4/3, the plus 4/3, and I'm going to subtract 4/3 on both sides. Okay, so that's going to leave me with x squared minus 7 over 3x equals, and then I've got 11/3 minus 4/3, which is 11 minus 4 over 3. 11 minus 4 is 7, so I've got 7 over 3. That's just a coincidence. I just made one up. I didn't know what was going to happen with it. It means nothing that we've got 7 over 3 for both of them. The other thing that we're going to need now is we're going to take this number right there, and I'm going to use it for the completing the square side work, and I'm going to put the side work right over here. And the idea is that we're going to take that number, and I'm going to divide it by 2, which is the same as multiplying by 1/2, because division is multiplication by reciprocal. So dividing by 2 and multiplying by 1/2 are the same thing. And what that's going to give me is I'm going to multiply top times top, bottom times bottom. That's how you multiply fractions. And 7 times 1 is 7. And 3 times 2 is 6. And then I'm going to square that number. But I'm not going to figure out what the answer is. I'm just going to write it as a square, and I'm going to use it. And what's going to happen is I'm going to wind up adding that 7 over 6 all squared and then subtracting it away again. And the reason I'm doing this is because I need to change what I've got here without actually changing it. I need to change what it looks like without actually changing what it is. And one of the ways to do that is to add 0 to it in some clever form. So this is our clever 0 here. And that's what we're going to use in order to do that. So we're going to have x squared minus 7/3 x plus 7 over 6 all squared minus 7 over 6 all squared, and it's still going to equal 7 over 3. That part hasn't changed. Okay? So now we've got something that we can work with. And in particular, I want to look at that piece right there. That piece is the completed square. That's why I had to do all the other work that I have done, was to get that piece. And the reason I needed that piece was so I could write it as a square. And the way you do that is you take this first thing and you write it without the square. You take whatever this operation is, either plus or minus, you put it right there, and then you take this number without the square, that's why I didn't square anything, and you put it right there. And then I've still got minus, and then the 7 over 6 squared after the minus, I'm going to actually square. And the way you square fractions is you do the top squared over the bottom squared, so it's 49 squared, not 49 squared, sorry, it's just 49, because that's 7 squared over 6 squared, which is 36, and it still equals 7 over 3. So I'm going to go to a new board now, and we're going to rewrite this. It's going to be x minus 7 6 squared. Okay, so x minus 7 6 minus all squared minus 49 over 36 equals, what did it equal? Equals 7/3. And that's what I'm going to start with here. And now the idea is that I have to get the square by itself, get this part by itself, and I'm going to do that by adding this 49 over 36 to both sides. And then I have to figure out how to do this problem right here. So let me do some side work for this. I'm trying to do 7 over 3 plus 49 over 36. And I have to get common denominators to do this, and it's always nice if the smaller denominator, the smaller bottom number, can be multiplied by something to make the bigger bottom number, and then you only have to do it on one side. So I need a clever version of one that does that. 3 times 12 is 36. So if I multiply by 12 over 12, then I can get common denominators. Then I'll have 7 times 12, which turns out to be, what is that, 70, 7 times 10 is 70, 7 times 2 is 14, so it turns out to be 84 over 36 plus 49 over 36, and then 84 plus 49 is, let's see, that's 13, carry the 1, 9 plus 4 is 13, so that's 133, so that gives me 133 over 36. Remember, the whole point is to get those common bottom numbers, those common denominators, so that you can keep that denominator and add the top numbers. Okay? So now I've got x minus 7 over 6 all squared equals 133 over 36. And there's really not a whole lot I can do with that big fraction. It looks big, it looks ugly, but it's going to work itself out, I promise. Okay? So how do I handle this? Let me make a little more room over on this side, actually, because what I need to do is I need to get rid of this square. And the way I'm going to do that is by canceling it with a square root. But if I square root that side, not only do I have to square root the other side, but it turns out that you have to plus or minus the square root on the other side to account for the fact that you squared something and got the thing inside the square root, and you don't know whether you squared a positive or a negative, because a positive number squared and the negative of that same number squared gives you the exact same answer. Okay? So over on the left here, the square root and the square cancel each other. So you have x minus 7, 6 equals plus or minus, and then the square root of 133 doesn't have a clean answer, so I'm just going to leave it that way. But the square root of 36 does have a nice clean answer. It has 6, and that is the way you square root fractions. You square root the top, then you square root the bottom, you do them separately. Okay? So now all that's left is to get the x by itself, and to do that I'll add 7 over 6, add 7 over 6 to each side. That'll leave me with just the x, and I've got this positive 7, and I'm going to take this and I'm going to kind of put it out to the front there. So I've got positive 7, and we've got common denominators, so I can put all the top stuff in one thing. So positive 7 plus or minus the square root of 133, and all of that can be over 6. And those are my two answers. Notice two answers because one of the answers is 7 plus the square root of 133, and one of the answers is 7 minus the square root of 133 all over 6. You could put those into a calculator and get some sort of weird decimal answer. But once you get to a point where you can put it into a calculator, why do we really care anymore? So that's the process of completing the square and getting the answer. Now, why is that important? Let me talk about that on a new page. This is important because even though you theoretically have the quadratic formula, what you can't do with quadratic formula is sketch something like, say, this. If I were to give you some function to graph like x squared plus 7x minus 4, okay, you could do some stuff to figure out a few points, but ultimately you're going to have to create tables that are pretty darn big. Or you can remember that the parent function, p of x equals x squared, looks like this. It actually touches down at the bottom there. And you can figure out shifting, and you can sketch an accurate version of this graph just by doing a few things. So if you complete the square, if you isolate that part right there and complete the square on it, so you'd have to take this 7 and you'd have to take half of it, which means 7 divided by 2, which is 7 over 2, and you'd have to make your clever 0 out of that. Okay, so it'd be x squared plus 7x, and then plus 7 halves squared, 7 over 2 squared, and then minus it again, so that you have the clever 0, and then minus the 4. Okay, so you've got this f of x equals, and your completed square is right there. So you can write it as your completed square. That x plus this plus is what tells you to write it as plus. Whoops. Plus 7x. That part doesn't change. Or no, I'm sorry, that part does change. Plus 7 over 2 all squared. And you might be asking, what happened to this 7? What happened to this x? Well, if you take this and you do the distribution on it, multiply it back out, you will see that it comes out to this entire thing up here. So it's hidden, but it's still there. You just don't see it. Okay? Minus 7 over 2 squared is 7 squared over 2 squared minus 4. And let's call it 4 over 1 and multiply it by 4 over 4 so that we get common denominators of 4. And so I've got x plus 7 over 2 all squared, and this is plus a negative, this is plus a negative, and that's going to be plus negative 49 over 4 plus negative 16 over 4. And so I've got f of x equals x plus 7 over 2 all squared plus, and then I'm going to do a little bit of side work here and figure out 49 plus negative 16 is like 49 minus 16, which is 33. So plus 33 over 4. And this then is something that I can actually graph just by noting shifting. Remember, shifting happens when you add or subtract things within that parent function, which again is right up here. Shifting happens when you start adding and subtracting things either grouped in with the x, like right here, or away from the x, like right there. So now we have two shifts here. We have a shift in the x direction, and shifting in the x direction happens opposite of what you see, opposite of what you would expect. So the shift in the x direction is negative 7 over 2. Shifting in the x direction always happens grouped in with the x. Shifting in the y direction happens not grouped with x, and happens as you see it. So this is a shift in the y direction of positive, or plus, 33 over 4, in the positive y direction, that is. So this then allows us to see everything that we need to see in order to graph this. We can make a rough but accurate sketch of the graph. We'd go negative 7 over 2, which is negative 3.5, right? Because 6 divided by 2 is 3, and another 1/2 would be 7 over 2. So it's negative 3.5, which is right there. So I'm going to keep that in mind. And then positive 33 over 4 in the y direction. If it was 32 over 4, that would be 8. So this is 8 and 1/4 more. So I gotta go up to like 9. That's gonna interfere with things a little bit, but that'll be okay. 4, 5, 6, 7, 8. Excuse me. 9. So maybe I should do the actual graph on a separate page here. Let me get rid of this graph, and we'll try it on a new page here. So just as a reminder, our parent p of x equals x squared looks approximately like that. It's a parabola. That's not a very good drawing of one, but that's okay. All we need is for a reminder. And we had our new function, f of x equals, what was it? X plus 7 over 2 all squared plus 33 over 4, which gave us some shifting. We had a shift in the x direction of -7 halves, and a shift in the y direction of 33 positive plus 33 over 4 in the positive y direction. And this is what's going to allow us to make this graph. 1, 2, 3, 4, so I can get to -3.5. 1, 2, 3, 4, 5, 6, 7, 8. And I've done it again, not left myself enough room. So let me do this in a spot where I have enough room. There, that'll work better. 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and -7 over 2 is -3.5, so we're talking there. I want to keep that in mind. And 33 over 4 is 8 1/4, so that's kind of like there. So I want to put a mark right about there. And other than that, this function should look like the parent function. It's just moved up and to the left instead. So there's the parent function, and here's our new function f of x. Looks like that. Instead, it's moved up and to the left. Okay, so that is using completing the square to be able to sketch a parabola without going through a table. Okay? And it turns out there are other things that you're going to need this process of completing the square for. When you do conic sections, circles, parabolas, or even parabolic, hyperbolic shapes, oblong shapes, ovals. Any of these are going to require completing the square for writing the equations in such a way that you're going to be able to sketch out the graph itself. The other thing that completing the square does, as you've seen, is reminds you of a lot of skills that you have to use to do it. Keeps you in practice with all those skills. But mostly, it's not a one-trick pony. That's the thing that I hate most about the quadratic formula, is it's nothing but a one-trick pony. All it can do is take a quadratic equation, give you an answer for it, and it's done. And things like that I absolutely hate. So I encourage you to maybe not throw away the quadratic formula as a tool, maybe, but at the very least, keep in mind that it's a very specialized tool, and that, on the other hand, completing the square is a tool that can do a lot of jobs and that you're going to use within the context of a lot of other jobs. So I encourage you, learn how to complete the square. Go over it over and over again, because as you do it, it'll become something that you can do faster. It'll become something that you can do easier all the time. And it's something that now when I use it, if I just use it in me doing a problem, the problem goes really fast for me. You can get that good at it. It just takes practice. Don't leave yourself without this tool. All right? Thank you, everybody. Bye.